All right, the next functional group we're looking at is carboxylic acids. Carboxylic acids. So a couple things I want to point out to you is the oxy here, oxy, and the acid. Okay, so we know a little bit about acids. Acids give off hydrogens in solution. So think about that sort of characteristic. And the oxy refers to oxygen, I guess. So you want to make sure you remember that there is an oxygen in there. So carboxylic acid is an organic compound that has a carboxyl group, okay? A carboxyl group, a carbonyl group bonded to a hydroxyl. So a carboxyl is a combination of the carbonyl group, which is the CW bonded to the O, right? So here's the carbonyl group, and here's the hydroxyl. So it's a carboxylic acid. It's a carboxyl. I'll go back out here. All right. So carbo and oxo. Okay. Carbon and oxy. Carboxylic acid. Yes? Well, the OH is a hydroxyl group. OH connected to only a carbon chain or something would be an alcohol. Yes. This is not an alcohol. This is not an alcohol. The OH itself doesn't make it an alcohol. It would be the OH. See, alcohols wouldn't have the carbonyl group there, right? It wouldn't have the carbonyl group. So because it has this carbonyl group, it is something different, but it's good question. So an acetate ion. Now think about a couple things here, guys. An acetate ion is an ion that's kind of left over after a hydrogen has been released from a carboxylic acid. So you would have heard this in Chem 30 before, the acetate ion, and we'll talk more about it as we move through. But a couple things that I want to show you here. This is the structure. This is how you would write an acetate ion. And actually, if you would, okay, well, actually, maybe it's down here. Yeah. So, well, not quite the same. So before this hydrogen is released, because you see we have a negative here, it's actually CH3 COOH. Okay? This is the acetate ion. All right. This is the molecule here, which we'll talk about, naming these here in a second. But this is the molecule that turns into the acetate ion. It releases this hydrogen. And if you've ever wondered why we write COOH, like the O separately instead of O2, it's actually a very important reason. It's because of the structure of this, okay? So we always write those O's together. We don't, or separate, we don't write them O2 because those O's are not bonded to each other at all. They're separate. And so that's why that is. The CO is a double bond here, and then the C to this O is a single bond, and that's where the structure comes from there. Okay? All right, so naming. Let's talk about naming. If you have a carbon root, a carbon chain, okay, that's going to be where you get your prefix from, methane for one carbon. And then if you have this carbonyl group and the OH group, if it's a carboxylic acid, you take away the ane, and then you stick on anoic acid. Okay, anoic acid. So methane, if you have this carboxyl group, it's methanoic acid. Okay, so anoic acid. So what's this one then that I drew over here? What is this? How many carbons does it have? Let's maybe I'll draw that out a little bit more in depth for you. So, okay, so we have C, right? And then we have another C, doubly bonded to O, singly bonded to OH. So if this is methanoic acid, what do you suppose this one is? You said it. Ethanoic, yeah. Because ethane, so it's ethanoic acid. Right? All right. So here we go. This is the ethanoic acid here, and here's where I guess I'll explain how this comes about. So ethanoic acid, also called acetic acid, which is the acid that's in. Anybody know? What acid is What common material that we consume quite regularly? Cough syrup? I don't think so. Could be in some, I don't know. Vinegar, that's what I'm thinking of. Acetic acid, vinegar. So the acetic acid here, acetate ion. So when this hydrogen, sorry, I'm trying to highlight, this hydrogen, when it gets released, we have an acetate ion. That's what makes the solution acidic. So this hydrogen right here, this hydrogen is pretty easy to come off. So it gets released into solution as an H+, or more specifically as an H3O+. It attaches to the water and makes the solution acidic. All right, properties and uses of carboxylic acids. They are polar, they are reactive. They dissolve in water and ionize weakly to produce hydronium ions, as we just mentioned. Because they ionize in water, soluble carboxylic acids have the common characteristics of acids, like turning blue litmus paper red and a sour taste. So that's easy. They're acids. They act like acids. They're pretty weak acids. Some have additional functional groups, such as hydroxyl groups, as in lactic acid found in yogurt. Lactic acid is also the acid that builds up in your muscles after a workout. That's why your muscles get sore if you work really hard and you don't flush the lactic acid out of your muscles. It aggravates your muscle and you get sore. So that's why if you're an athlete, as I was back in the day, if you work out, have a practice, have a game, you should cool down a little bit, and you should go for a light jog. You should get on the bike, skip rope, something like that, to kind of get your muscles moving just lightly. Even if you're dead tired, you should keep moving for a little bit just as a cool down. What that does is it flushes the lactic acid out of in between your muscle layers, and then you don't get, you're not sore. So if you work out and you're so dead tired, it's like, oh, I'm just going to go lay down, and you don't do anything to flush that lactic acid out, it builds up and gives you pain. So that's why you get really sore. So it's a good idea to kind of go for a little jog or do something. When I was playing hockey down south at university, I would skip rope. That was my thing. After every practice and game, I would skip rope for 10 minutes or something like that, just to kind of flush the acid out. Typically, these acids are more soluble in water and often more acidic than acids with only a carboxyl group. Okay. So draw the following carboxylic acids. Okay, so if we have butanoic acid, pretty easy, right? Pretty easy, butanoic. 1, 2, 3, 4 carbons in total. So meth, eth, prop, bute. So you would count the carbon there that is on the carboxyl, in the carboxyl group. And these carboxyl groups would always be at the end of the chains, hey? They'd always be at the end of the chains, so, yep. Okay, good. Yeah, quick question here. Student had some additional functional groups. This last line is referring to the carboxylic acids that have additional functional groups. Yeah, they're more soluble than just sort of plain carboxylic acids. So if they don't have the extra functional groups, yeah. Like I say, some of these uses and characteristics, you want to study these uses and characteristics, but you don't have to memorize, each point here for sure. Just hit the highlights. Okay, so drawing, heptanoic acid also could be, septanoic acid or whatever. If you put the OHs together, that's great. If you separate the, bond with an O, bond with an H, that's totally fine too. All right. So just by means of review here, I do have a couple things, a few things highlighted here, just so we can compare and contrast the different functional groups that we've studied with the carbonyl. Okay, so the carbonyl is the C doubly bonded to the O, right? That is the carbonyl group. A carbonyl that is attached to, C is attached to an H only on the one side, that's the aldehydes. Okay, so you could have a carbon chain or ring over here. But if you have C doubly bonded to H and then just, or O and then just an H over here, that's aldehyde. Ketone has a carbonyl group and carbons on either side, carbon ring or chains, that's ketone. And now our carboxylic acid has the carbonyl group and an OH and also a hydroxyl. So carbonyl and hydroxyl. That's where the carboxyl comes. Okay, so it would be really good to make sure you remember the difference between those four things. Okay, so that's the carboxylic acid Groups, any final questions before we move on from carboxylic acid?